Good morning, I'm Liang Jie, and this is Rajat. We are Teredo Analytics, a deep tech company that strives to determine detrimental pipelines condition using smart data collection and data analytics. Currently, there are 3.6 million kilometers of pipeline in the world, with the majority of it comprising of oil and gas pipelines. This is not surprising, considering that 36 billion barrels of oil are produced each year for the world consumption. This puts the market value of the oil and gas industry at $1.7 trillion US. But despite the heavy investment in pipeline inspection and maintenance, there are still 1.6 pipeline incidents per day, which not only lead to a financial loss of $500 million US per year, but also lead to irreversible damage to the environment and even loss of life, which cannot be quantified financially. Now let's look at the current methods of pipeline inspections and their limitation. To your left is a pipeline inspection gauge, also known as a PIG system. As you can see, deployment of such a system into the pipeline can be extremely laborious due to its massive size. And in addition, this PIG system will often get stuck within the pipeline itself. As for water pipeline, current methods can only detect existing leaks. And even when it comes to detecting existing leaks, it comes with a relatively high false alarm rate. And currently, all inline methods of pipeline inspection are non-navigable, as they cannot make a turn when it comes to making them to a bypass pipeline for inspection. As for non-piggable pipeline, which is of small diameter pipeline, a safety inspector is tasked to walk along the entire length of the pipeline, which can be extremely time-consuming. Now, the Teredo Observer serves to address all these current issues. Firstly, it is modularly designed for easy change of sensors to meet the customer's different requirements. In addition, different arms can be attached to the different length arms can be attached to the observer, so that it can traverse in different diameter pipeline sizes. And once inside the pipeline, it can detect differing pipelines condition using its onboard sensors. And lastly, of course, it can be pre-programmed to navigate to a designated pipeline for inspection. Now let's look at the operation capability of our observer.
Our device has adjustable arms to accommodate different pipe sizes. It also has the flexibility to attach different sensors to measure acoustics, pressure, and visual data. In a typical deployment scenario, the docking station receives the signal to release the device for pipeline inspection. During this pipeline inspection, the device tracks itself using the rollers installed onto it. Our device is also capable of detecting leaks using the pressure and hydrophone data it collects while traversing. It is also capable of detecting abnormalities using pressure, its own speed, as well as the visual information. Now, one of the unique features of our device is that it can autonomously travel to the designated pipes, and at the end of it, autonomously dock itself for the next deployment.
Now, the current oil and gas pipeline safety market stands at US $7 billion. And the serviceable available market stands at $1.7 billion, which is in the Asia Pacific region. What Teredo Analytics target is the serviceable optional market of $15 million US, which has a small diameter pipeline, which are non-piggable at the moment. So our business model will be based on a pipeline inspection package. It can be a monthly package to inspect a certain number of length of pipeline, or it can be a project-based, or it can be an annual contract. Majority of effort will be put into pipeline data collection, followed by analysis report and pipeline product data collection. Now let's look at our competitive landscape. So there are companies like Emerson and Rosen, which are only specialized in piggable pipelines, which is pipelines of large diameter. And there are companies like Pure Technologies that can put their device into non-piggable pipelines also. However, all these devices are non-navigable, and Teredo has the advantage of making itself unique to the competitive landscape by making itself autonomous, by having the autonomous navigation function. So we have make a market survey, and there's a demand for our service in the water pipeline market too. And also due to its low barrier of entry, our first commercial customers will be from the water pipeline network. Followed by that, we'll tailor our device for the water pipeline network, and we have continued engagement with the oil and gas industry. And by the end of 2020, we have finished our device for the water pipeline network, and we get our first contract, and we will start our development for the oil and gas device. And towards the end of 2021, we have a recurring yearly contract for the water pipeline network, plus our first contract for the oil and gas customers in Singapore. So in year one, with all our funds gathered, we are confident that we can develop a device for the water market. And once you are into the market, with the recurring revenue generated, we use the money to develop our device for the oil and gas market. And for year three, all our expense effort will be to expand our services and marketing to the ASEAN region. So I'm Liang Jie. I'm the co-founder of Teredo Analytics. I'll be in charge of business, machine learning aspect, and image and data processing of the company. I'm currently working on a project with Kappa using acoustic data also, and we are assessing how much rare earth minerals there are on the seabed. And he is Rajat. He's currently a PhD student, and his interest and his thesis is on robots in environmental monitoring. And the company is supported by Professor Manda, who's the head of acoustic research, and Mr. Derek Lee, who has more than 15 years of experience in the oil and gas industry. And with that, I end my presentation. Thank you.
Thanks, Liang Jie, for the interesting talk. Let's see if there are any questions from the floor.
Hi, maybe a quick question. I would like to check. Oops. Can you tell us a little bit more on what exactly being captured on the data? I think it's not just a leakage, right? What about chemical or biological, so maybe bacteria or something like that, falling?
Yes, so we have designed our device to be modular in design. So if the customers is interested in what you have mentioned, we can actually swap the sensors out and put in what they are really interested in. Yeah.
Hi. Thank you for your presentation. Now, you say that the vehicle is, or the device is autonomous. So when you put it into the pipeline and there is a flow, and you want to hold it at a particular point to capture the video image or whatever it is, then you are acting against the flow. So that will be consuming significant amount of energy, and your battery pack, just wanted to know how much is the battery pack and how long you can go for the inspection.
So to answer your first question, our device will make use of the flow of the product to push it along, and you'll be collecting numerous data at every second. So it need not stop at a particular point. Yeah. And as for the battery pack, currently for our prototype, we're using a 4,200 mAh, and this allows us to last for 7 days of continuous operation. However, we will not be operating that long a period. So the battery pack is more than enough to sustain our operation.
Thank you very much for the presentation. You said your immediate addressable market is 50 million, and that you're going to focus first on water inspection and then maybe a pilot oil and gas. Is that your assumptions for your first 50 million? And then a related question, assuming you conquer your first 50, what are your steps to go to the 1.7 billion?
So the 50 million comes from our research. It's based on the total non-pickable pipeline in the ASEAN region. That's right. Yeah. So we actually found out that there's a lot of water pipelines in Singapore too. In fact, there's 6,000 kilometers worth of pipeline in Singapore, and they're actually inspecting the pipeline on a 100-kilometer basis, as in they aim to inspect 100 kilometers worth of pipeline every year. So this is a valuable market for us too. So once we have established ourselves in Singapore, next will be the ASEAN region, and next will be the developed countries such as Australia, New Zealand, and Japan, where they treasure their waters pipeline. Yeah.
Okay, I have one question. Could you elaborate more on the modular design that you mentioned?
Sure. Similar to the question which that gentleman has asked, so our modular design allows us to adapt our device to different inner diameter pipe size. For, let's say, if there's a certain hydrate growth within the pipeline, our leg or our arm with a spring-loaded design will actually allow us to traverse through this growth, so you not get stuck in it. Yes.
Okay, clear. Okay. Any other questions, please? Gentlemen.
When you say about pipe size, can I know how small you can really go down to, number one? And then number two, if this is going in the product flow for water, how about for gas? The gas has to be shut off, right?
So the reason why we came up with this product is to allow our device to inspect the device without having to stop the product flow. So the product flow is actually the catalyst for pushing our device along the pipeline. So because our device is scalable, and with the advancing technology, we can make it really small or make it really big. It really caters, so that it can cater to the different diameter pipeline which the customers has. So it's scalable.
But in oil and gas, I mean, if you're talking about gas pipeline, that product can be dropped in there and just run water gas in operation?
That's right. For that to happen, we will have to get it IS certified. So the current standard is IEC 60027. We have to get it certified in order to do that.
So you can work on different types of pipe material, whether it's metal or it's polymer?
That's right. So one of the secret sauce is machine learning. We're using it to adapt to different pipeline conditions, different materials, and different viscosity of water. Yes.
Thank you.
Thank you.
Okay, we'll take the last questions from the floor.
Your assumption, I mean, the assumption is that it is ambient temperature pipes, correct?
Not necessarily.
Okay, then how high can you go and how high for your next prototype, high temperature pipes?
So it really depends on who our customer is. For the water network customers, the entry bar is not so high, and the device need not be so stringent. We will certify our device to IP6810, which is the standard. Whereas if we go to the oil and gas market, and it depends in the oil and gas market, is it for water? Because there are some water pipeline which they have, or was it for oil or gas? And depending on the temperature, we will have to cater our device accordingly to the different standards which they have. Okay, thank you very much.
All right, that's all the time we have for Teredo. Thank you very much.